Hello everybody, welcome to my channel. This is Shiva Ravindra. Today I am going to explain you one more perk, that is complex efficacy programming. So most of the programmers as well as who are interested to join in a clinical SAS field, so they are some familiar with this safety related thing, but unable to answer the efficacy related question and answers, as well as in the real time also who are having below 5 place or 6 place, they are unable to do the efficacy programming. So everybody getting a fear about the efficacy because it little bit complex. Even me also agree, but in this part, so I am going to explain you so how to write a different efficacy programs. Okay, so these codes very much helpful to your real time project work time, as well as whoever having some basic idea about the SAS also. These videos very much helpful to understand the efficacy concepts. Okay, so this is a programmer point of view, not the statistician point of view. Statistician given some patch of code to getting the p-value. Here in this I am going to write a scratch programming for every output. So I am planning to provide this part, and every week I am going to release two videos, two different types of efficacy programmings. Okay, so in this class I am going to explain you two efficacy programming. Okay, if you want to watch these videos, please pay 399 rupees, so that you can join this park, and this and you can view the codes in this playlist, complex efficacy scratch programming in detail playlist. You can find the videos. Okay, so my first program is subject demographic sex and age safety related population, and here this is the shell. So we are going to write the programming for this one. So how to get the p-value. So here footnote they mention how to get the p-value, which method we need to use. Okay, so chi-square and exact method, they are in the statistician instructed us to produce the p-value using this method. And the second table is analysis time days in response using Kaplan-Meier method and using Clark regression model. Okay, regression model. So this is the shell. Okay, so in this you can see censored by region, number of event, Kaplan-Meier estimates, and p-value, hazard ratio. How to get these p-values I'm going to explaining in this video. Okay, so every week I'm going to release two videos. If you want to watch these videos, please join my YouTube channel, and here there is a option here. If you are clicking this join button, so you'll get this section. Okay, so this is for 150 questions as interview question and answers, and you can click the join 119 rupees. You can find all 150 question. If you want to join this complex efficacy, you can click here, you can join this one. So if you are interested to learn all projects, so you can click on this BABE clinical project, 3,999 rupees. By joining button, you can if you are taking this uh, course, so you can automatically access to these two perks as well. Okay, so no need to pay extra this one. So if you're taking 3,999, so you can able to watch this. If you are able to take this complex efficacy, so you can easily able to watch this 150 SAS interview question and answers, as well as this complex efficacy programming. So this week only I started. So every week I'm going to release two different types of efficacy programmings. Okay, so we are going to start our programming for first table. So this is the shell. Okay, so subject demographic, sex and race, safety population, p-value. How to get the counts and percentages, and how to get the p-values. I'm going to write the code. Okay, so first of all you can check. So in the Adam we have ADSL dataset, ADSL. So we have how many subjects? 6 subjects are there. Okay, so first of all start the dataset. Adam dot ADSL. So out equal to ADS. So what are the variables are required? You can keep those variables. Subject and TRT01. Here we are using plan treatment. So plan and actual treatment both are similar in this project. So if it is a different, you can take the actual treatment for safety table. Okay. So plan treatment TRT01P and 6 and race variables. Okay. So by subject and run. Okay, you can take as efficacy 1_1. So 6 subjects are there. Okay, so you can look at the ADSL. Okay, subject, sex, race, plan treatment, and this one. Okay, so now just count the capital N counts. Okay, so here they mentioned the capital N counts, right? So we need to create a macro variable to get the capital N count. So I'm using into class method to create the macro variables. Okay, so create table, some TRT as select treatment. Okay, so count of distinct use subject ID as, so I'm giving the variable name as denom. Okay, so from which data set? ADSL data set. Okay, so group by TRT01PN and TRT01P. Okay, so order by TRT01PN and TRT01P and quit. Okay, so in this TRT dataset you will find the counts, right? So 3 subjects, 3 subjects. Now we are converting them into macro variables. Select this variable into class method. Into class method. So I am creating the variable name as M1 to M2. Two treatment, right? From which dataset? TRT dataset. And if you want to check whether they are created or not, so put ampersand M1 ampersand M2. So here you can see M1, M2, three subjects are we created as a macro variable by using into class method. So next coming to the body part. So gender counts and percentages p value, race counts and percentages p value. So next gender counts. Yeah, by using proc frequency method. So it is a categorical data, right? So that's why we're using proc frequency method. So ADSL. So don't want to print this into the output window. So that's why I'm writing no print option. So tables, sex variable versus TRT01PN. So out data set I am giving as gender. So here we are dropping the percent. Okay. Why? Because we are manually calculating the percent. What are the default percentage we get? So ignore that one. Okay. So now the gender data set, you will get the counts. You can see, so count. Second treatment, female subject 3. First treatment, male subject 3. Okay. So next we need to do some customizer as per the shell. Data, gender, set, gender. Okay. So category equal to here So how to display this one? The category equal to gender, right? So here category equal to gender, and I am giving one numeric version variable also for this gender. Okay, and if sex variable equal to m, then do start variable equal to male. As per the shell, it should be like this, right? Male, and I am giving the one variable name as numeric version start equal to 1. Why? Because so according to the shell, male should be first and female should be second. If you are directly using the variable in the by statement, it is goes as a alphabetical order. To avoid that one, so we need to give one number this one, two number to this one. Okay. So next, if it is a female, so you can give female. Okay. So it is giving as a two number. So you can, to avoid the truncation problem, you can give the length statement of these two variables, stat and category. Okay. So you can give up to 50 is fine. Now you can see category gender, category 1 and female, statistics female and male, sorting order 2 and 1. Okay. So next you can sort the data set by the cat and by sort. So you can give run statement. So now male first, female later. Next same applicable to, so we'll get a counts. Okay. So we need this p-value also. So p-value what they means chi-square method. So the statistician, even if you are asking, they will provide you the uh, syntax as well. So here the chi-square method, same proc frequency method, data equal to ADSL, tables, sex variable versus treatment variable. Okay. So just you can mention the chi-square. Okay. So backend dates, some data sets are created. To get the data set, you can write the ODS trace of ODS trace on. Below you can write ODS trace of. So that what happened, so backend what are the data sets are created, you can able to see in log window. Okay. So any efficacy procedure, you can write the proc ODS trace and trace of. Here you can see cross tab frequency was created, chi-square data set were created, Fisher exact also created. So in this you can pick out the chi-square. Okay. So chi-square test you can pick up. Okay. So this one, either this one, either this one. So both are, this is the label, this is the data set name. Okay. So here ODS output. So I'm picking the label chi-square test equal to, so I'm giving the variable name as chi-square. Okay. So here the chi-square data set I created. So many probability values are there. So which one we need to pick? So this is the chi-square, right? So data, so underscore p-value 1. Okay. Set which data set? Chi-square data set, right? Chi-square and if statistics equal to, so I am giving uppercase which variable, statistics equal to chi-square. So this one, chi-square, then do, so I'm creating the variable name as p-value. Okay, so this probability values are in which format? So it is a numeric format, so I just converted them into the character format. So here I am directly using p-value 7.3 format. So directly it is a, we can get the up to 3 decimals. Okay, so cat n equal to 1. So same category n equal to 1 we are giving, right? So for merging purpose we use cat n 1, same here. Okay, so output and stop and end and run. Okay, so do end stop. Okay, so here we are going to keep only few variables. Keep p-value, so cat n and test. What is no test, only this one. Yes, p underscore value 1. So we have, so first variable p value we are getting up to 3 decimals. Okay, so next coming to the race part. Okay, so the race part also same thing here. So up to here I am copying. So now up to here I am copying. Okay, so just here in place race. So here also you can replace with race, and here also you can replace with race. So race we are getting. So race. So these are the race and these are the counts we are getting. So here you can give the race and category. I am giving 2 number. So what are the categories are there? Asian, black, white or others. Okay. So first one is Asian. Race equal to Asian. Then do how it was going to display like this, right? So it is a race and race equal to next one is black or African or American. So we are giving same thing, sorting to next one white. So white they want give the third row. So white I am giving third 3 and next finally other. Okay, 4. And data name also you can change it as race. Same how the sex frequency we are getting, so same way we are getting the race also. Okay, so race as in sorting. So you can sort the data set. Okay, and next coming to the this method. Okay, so race p-value what they are asking us to. So it is a chi-square and this is a Fisher exact. So race p-value exact method they are asking, right? So here ODS output here race. So here chi-square place you can mention exact. Okay. So here just we can run. So what are the backend data sets were created, based upon that we can decide. So Fisher exact was created. So now we are using ODS output Fisher exact equal to. So whenever you are using label, so you can put the double quotation mark. Otherwise, you can directly use the data set name Fisher. Okay. So here I am creating Fisher. So here also XPT underscore fish is there, right? So we need to pick this one. So p value 2. So here Fisher. So uppercase of name 1 equal to XPT underscore fish. So p value equal to, so this is numeric version value. So we are converting this into character. Otherwise, you can directly take this one also. So numeric version value category equal to 2. So this is the p value, 2 p value. So now we get all the data sets, right? So gender information and p value. So we are calculating data, gender. So merge gender and this p value by caten and run. So now gender. So we'll have p value also. Okay, along with the statistics, p value there. So the same way. So race p value 2. So rails also we have p value. Okay. So now we're done with the race calculation. So now we are going to count the percentages. Okay. So percentage calculations. So data. Yeah, percentage calculations. So data equal to some final, and set this gender and race. Okay. So just run this one. So we'll see. So all the information related to gender and race I just set together. So in the final data set, we have male and female, and the statistics will get, and p value also we will get. Percentage calculation. What is the percentage calculation formula? Small n divided by capital N into 100. So we already created the macro variables for the capital N, right? M1 and M2. Now we are going to calculate the percentage. Okay. So here what is the count variable is count, right? So if our treatment equal to 1, so I'm writing the simple code, then do. Okay. If for example count in dot or 0, then I'm creating the one variable called grp. So that time we have to give the 0. Okay, so if it is in a dot or 0, so we'll get a 0. Else, if it's a count equal to some capital M1, because macro variable we created the treatment one is M1, right? So it is both are equal. So in that cases we will get what? 100%. So in that cases GRP equal to, so put of this count. So I'm giving approximately 3 dot. So and we'll give the 100%. Okay, obviously we'll get the 100%, but why we are giving like this? So nowhere we are going to represent 100.0, right? So for that purpose I directly given the 100%, because count is equal to the capital N count, we directly giving the 100%. So if not cases, so GRP equal to, so put of this count comma 3 dot, okay, count, and next we have to calculate the percentage. So percentage is also we need to open bracket and this count divided by this M1 into 100, so up to 1 decimal we have to represent. Okay, then closing bracket and just end, and we can give the length of the GRP around 50 is fine. Okay, so then dot counting expecting a, then GRP equal to 1 to close and open and close. So now final data set will get the grouping variable, okay, for the first treatment. So in the same way you can do the second treatment as well. Okay, so second treatment also we have only 2 treatments, right? So directly you can give the second treatment, and you can the macro variable we created for second M2, right? So M2. You can see the counts and percentage variable also you'll get. Okay, so now we can transpose the data set. Why? Because transpose, so here the treatments are in a column wise variable. So for that purpose, proc sort by caten and sort run. Okay, so proc transpose data equal to final, so out equal to all underscore trt. Okay, so I am giving some prefix equal to t. So by variables are caten and category variable and sort statistics variable and p value also I mentioned. So id variable is trt variable, so var variable equal to grp variable. So now all underscore trt we can see here. So these are the t1 t2. So wherever missing was there, so we can assign that as 0. So data all underscore trt, set all underscore trt. If t1 equal to missing, then t1 equal to 0. If t2 equal to missing, then t2 equal to 0. Okay, so as well as if any p-value, so we are not going to represent all rows, so first row is fine. Okay, so for that purpose, if sort greater than 1, then do p-value equal to missing. So no need to represent all places, only one place is fine. So all underscore TRT will give. So only one place is fine. So overall race, this was the p-value, right? So wherever the missings are there, so we are replacing with the 0. So now we are going to write the proc report section. Okay. So proc report section purpose. So there is a macro for getting the outputs in this RTF specified structure manner. Okay. So RTF style macro, it will give all these things. After that one, proc report you can write. So title 1, justification equal to left alignment. So first title 2, justification equal to left alignment. Okay, and next title 3, justification equal to center alignment. Okay, so title is done. Next footnote 1, justification equal to left alignment. So the lines were not required, so that is a mark. And footnote 2, justification equal to left alignment. Yes, fine. Next options. Orientation equal to, so it is a landscape. And ODS escape char equal to, so I'm giving some cap symbol. And ODS RTF equal to, so where we need to store this one, so I am placing one place, so here this one, just I am giving the path where you are going to locate this one. So T1 table, right? T1 underscore 1 dot RTF. So style equal to, so what is the style? So styles.test. So if you are not giving this one, default RTF file will generate. To avoid this one, so we need a specified required RTF, good looking RTF, right? So that is why the RTF style macro was given. So in this, they will mention the bottom line margin, top margin, how much font, what is the font, etc. Everything was mentioned. Directly you can give this one. So automatically you will get a good looking RTF file. Otherwise, the default RTF file was produced. Okay. So proc report data equal to all underscore TRT. Okay. So no window split character equal to, so I am giving the pipe symbol wherever we need a split, so you can use this one. So whenever we have a missing value, so we can include those also. Okay. So next style equal to output width equal to 100%. So any longer text is there, so we are wrapping the text. Okay. So column statements you can mention category variable, sorting variable, and statistics variable, and treatment T1, T2 and P value variable. Okay, so now we are going to define each and every variable. Define cat10 order no print. So next define category variable display. Okay, the label is category. So style column equal to, so justification equal to left alignment, cell width equal to 10%. Okay, next define the header as well. Header justification equal to left and same thing. So say two variables were done. So same way start and starts also you can define. Start and start and statistics variable statistics giving the same length. After that one T1, T2 and P value. So this is the T1. So drag A and split character and capital N equal to ampersand M1. So open and closing bracket. So the next T2. So T2 is drag B and M2, right? So automatically it was going to resolve. Next P value. So probability value. So probability value. Okay, you can give like this. Okay, so after that one, so compute. So there is a below line and after line also we need page compute before underscore page underscore. So there is a line needed, right? Here you can see this one, there is a above line and below line. Default if you are not getting that line, so you need to give a special code line @1. So it is you can write like this. So cap symbol. So here we are escaping that cap symbol, right? So without this one, so it is not going to resolve. So you need to escape that character. Okay, style output width equal to equal to 100% and border top color equal to black and border top width equal to so 0.5 pt. The end come. So the same way before and after also you can draw a line and after that one you can run this one and you can close the all ods underscore all underscore close. Just run the output. Now we'll get this was not resolved, so we need to check. So category and this one also not for this one. So we'll see why it was not resolved. Category also you can give group. And now it was not printed. So above line was not printed, below line was printed. So what is we done? Style output. Oops, I tried to add this one. So we are not getting anything error. So border bottom color equal to border bottom width equal to border top bottom width. So we are not getting any errors even though it was not resolved the first line. Yes, it was resolved. So gender and category, so it is the p value. So even the footnote also you'll get and titles also you'll get. You will get a perfect output. Okay. So if you like this video, please join my YouTube channel. So to paying by $3.99, you will get a more and more efficacy related coding. So the next video I'm going to show you how to write the coding for this one. Okay, so how to write the coding for this Marshall. This is also more complex efficacy table. So in the Kaplan-Meier, you have heard so many times if you are hearing about Kaplan-Meier efficacy table. So next video, I'm going to write the code for this one. Okay, so if you look at this one, so when this is a more complex table, so in this Kaplan-Meier estimates, improve, p-values, hazard ratio. So only the members who are joined the 399 rupees package, they're only those persons only able to watch the video. So I'm going to make this video by 1 or 2 days and upload into that particular playlist. Okay. Thank you everybody. Thank you so much. Bye.